Hey there, I'm Nix, and the topic of today's video is solving the 2-sum-2 problem with a sorted array on the LeetCode website. As always, solving this problem in the C++ language and giving you a detailed explanation of the entire process, through the planning of the algorithm, to the coding of it, to the analysis of its time and space complexities, as well as looking at LeetCode rankings. If that sounds interesting to you, then stay tuned. Welcome back. Now for this video, I'm going to show you two methods. The first of which is not actually going to work. And you'll see why I'm going to show that to you soon. The second one will, of course, as you might expect, we'll use a two-pointer technique to be able to solve it. But let's read over the problem and see what we're getting ourselves into. We're given an integer array, numbers, and it is already sorted in non-decreasing order. We want to find two numbers in it such that they add up to a specific target number. We want to return the indices of these two numbers in a one-indexed system. So when we find the indexes in our array, we're essentially going to have to add 1 to it in order to convert it to a one-index system, since arrays, vectors, strings, etc. in C++ are all 0-indexed. Now we want our answer reported as an integer array of size 2, and the first value is going to be less than the second value, which is going to be less than or equal to the length of the numbers array. And the tests are generated such that there is exactly one solution. So we don't have to worry about negative scenarios where nothing adds up to the target, or where we have multiple possibilities and we see we need to find the first one or all of them. Nope, we just have one specific solution, so we have to find those two specific numbers. And there'll always be two because we're not allowed to use the same element twice, so their indexes have to be different. Now we have some handy-dandy examples here, and as we can see with this array, our target is 9, so 7 plus 2, being 9, is our answer. 2 and 7 occur at index 0 and 1 in the array, so we report 1 and 2 by adding 1 to both of them. Constraints: the length of the numbers could be from just 2, in which case finding the two numbers is easy, to much bigger than 2. Values can range from 1,000 to negative 1,000. We already know it's sorted. We already know that there's exactly one solution. Okay, so as I said, I first want to go over an quote-unquote almost solution. And I want to show this because one, it could be if you're just trying to solve this problem without this explored card and thus without the pretty clear hint as to what to do to solve the problem, you might have this brute force method pop into your head initially. That brute force method is the one that involves using a nested for loop. Create a vector of integers to house the answer, create a nested loop, and check to see if the two current values you're looking at, when added up, equal to the target. If they do, plop the indices plus 1 into the array answer, and then return the answer. So let's look at that code, which is right here. As I said, here's the vector of integers housing the answer, which is given a size of 2. And the first for loop goes from the beginning of the array to the penultimate value, the next to last. So we're going as long as it's less than numbers.size minus 1, so that last index. We want to be lower than it, so the next to last. Now the second for loop comes in, and j goes from I plus 1 all the way to the very end of the array. And then as long as I is not equal to j, and as long as the two values, when summed up, equals the target that we're looking for, then let's add the indices plus 1 to the answer vector, and then break out a little loop. Last thing we need to do is return the answer. So as you'll see, this does initially work and can work for small input values. However, when you get toward larger and larger array lengths, because of the nested nature, this solution, while it does work for some cases, gets slower and slower and slower the bigger the numbers vector becomes. Because it depends on it twice, because we have nested loops here, this would be a big O of n squared time complexity, which is slow. So although it can work, and although this might be something that can pop into your head, LeetCode doesn't like it when you do the full submission. You'll get a time limit exceeded here. So this situation could easily be run into if, say, a technical interview asks you this kind of question. And initially, you can have, say, ideal constraints placed upon you, where you might be given a small input size. However, once you get this brute force method, your technical interviewer could ask, well, that could work for small input cases, but what happens as the output gets larger? Do you understand the time complexity of this one? Is there a faster way? So it's a way to break the ice and then make the problem a little bit more complicated, which LeetCode does by just complaining about the time limit exceeded. So I wanted to show this non-solution to you before we officially move on to actually solving the problem. So with that done, let's actually solve the problem. And as I've alluded to several times, we're going to use 2 pointers, essentially 2 position trackers, in order to be able to solve this. Now let's look at this array here. We know we're going to need the answer vector, but what other variables are we going to need? Well, if we're using a 2-pointer technique, why don't we start with the first index and the last index and see what they sum up to? Well, in this case, we'd get 17, which is bigger than our target. Since our sum is bigger, well, because this array is sorted and we know our position at the end is going to be the largest number present in the array. The number at the beginning is going to be the smallest one. So if our sum is bigger, well, we know that moving the end position down by 1 will make the sum smaller. On the flip side, if we ever had a situation where our sum was smaller than our target, we know that moving the beginning position up will increase our sum because we'll move on to a bigger number. But with this movement, we have 11 and 2, which is still bigger than our target. So we have to move our, say, ending, or the one that is the rightmost position, down 1 again. And then finally, we get to a situation where we're getting 7 and 2, we add it, we get 9, and all is sunshine and rainbows. So with those 2 positions, we can solve that problem. We'll have our vector answer, and we'll have our 2 integers that serve as our positions, starting and ending, left and right, whatever you want to call them. Then we're going to have a while loop, and we're going to loop until our starting position initially essentially becomes equal to or bigger than our ending position. So with 3 variables, the while loop, and looking whether or not we found our target or whether the sum is bigger or smaller, we can adjust positions accordingly. And then once we find our target, we can add those to our answer array in a very similar fashion that we did here, and then return our answer. So let's move on to coding that out. All right. I deleted the nested for loop that was here and left our answer vector exactly as it was. And I left a return statement because I'm going to need that eventually anyway. And I've added 2 integer variables here. I've named one the left position, which is going to be set to 0, and it's going to be located at the start of the array. And the other one, named right position, is going to be set to the last index of the array. So it's going to be at the end. Now the framework for the while loop comes in. So as long as left position is less than right position, we're going to do stuff. And the stuff will be housed in the 3 main branches here. First one, we're going to sum the value at the left position, so numbers left position, plus numbers right position, and see if that equals the target. The other scenario is when that summation is less than the target. And the final situation is when that summation is bigger than the target. But since that's the only possible situation left, we don't specifically have to write that out, and we can just leave it to the else statement here. Now the first if statement here is essentially what the if statement did in the previous non-solution. We found our target. We want to put left position plus 1 into our answer vector, and we want to put right position plus 1 into our answer vector. And then break out of our loop because we found what we wanted. Once we break, we can return said answer. Now in the situation where the sum is less than the target, we know we need a bigger sum, so we want to move the left position up by 1. And of course in the else statement, if our sum is bigger than the target, well, we need to lessen the sum, so we need to decrement the right position by 1. And with that, the code will be complete. Now let's go through and see if this will run correctly. Finished. 1, 2, 1, 2. Excellent. Now, we want to see green text, which we should because this runs faster, and it does. Excellent. Now looking at time and space complexities, we essentially have 3 constant space variables. We have created a vector of integers, but it's always going to be equal to the same space. Size of 2 is going to be present in all situations. So that size it's carved out is constant. We have 2 integer variables here, so those are obviously constant as well. So I would say that this specific algorithm does have a space complexity of big O of 1. It takes up constant space. That is independent of how big or small the input size is. Now for time complexity, we do not have big O of n squared, which is nice, and which is why we got green text. Instead, we only have one while loop here, and its condition is such that it's going to just go through the array, in the worst case scenario, all the way through once. It could run at minimum just one time if, say, the first value and the last value here initially are actually the ones that you're looking for. Or it can run through the entire array because the last 2 numbers that it looks at are the ones that you finally see in this situation here, where it has to look at all of them before it finally hits upon 7 and 2. But the number of iterations it does is dependent on the size of the numbers array. Bigger the array, the more iterations it's going to run. But all of the if statements here are doing constant time work, so it only depends on the number of iterations in this while loop, which depends on the number's size. So this solution's time complexity would be equal to big O of n, where n is the size of numbers. And that is definitely a big improvement to the previous non-solution. Now the last thing to do is look at the rankings before we end. And I've seen the solution kind of ping pong all throughout because, as you can see, it has a tiny distribution variance here. And the memory, I've also seen it ping pong around because, again, it doesn't really have a big range in how the various solutions are distributed. So whenever that occurs, you usually have more tendency to ping pong around. With that, that was how to solve the 2 sum 2 problem on the LeetCode website. I hope you got something out of the video. If you did, consider subscribing. And as always, I will wish you happy coding and to have a nice day.